Okay, welcome in Jesus' name. Welcome to this video. We're talking about electric field and magnetic field. So, as I've always said, all our videos is to help you gain good grades in academic, to make yourself proud, make your parents proud, and make your tutors and everyone with your colleges, university proud of you. Do you understand this? But you need to pay attention, jot the necessary things, and solve more examples and exercises on these topics. Do you understand? So I'm merely teaching you how to approach questions with confidence when you see them. Do you understand that? So today we're going to be talking about electric field and magnetic field. So I have a little introduction here. So this is what I have here. So under electric field and magnetic field, they say the electric force between two charges Q1 and Q2 separated by a distance r is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. That is Coulomb's law. Do you understand? So once you know the derivation, you'll be able to explain it. So this is what I'm saying. They say under Coulomb's law, we have F is directly proportional to the multiplication of charges, and F is inversely proportional to the square of the distance between them. So when you join them together, so you have F is equal to K Q1 Q2 over what? R squared. K is a constant. I'll pay attention. So the constant is always given as 1. The constant is always given as 1 over 4 pi e this. Do you understand? So you just need to know this. So under electric field, so it's given as this. So it also has a value of 9.0 times multiplied by 10 to the power of 9 n m squared inverse. Do we understand this? So we also have the general formula that's given as Q1 Q2 4 pi E0 R squared. I hope paying attention. So this is the general formula under Coulomb's law. Do we understand that? So we're going to apply this formula to solve related questions over there. I hope paying attention. So, okay. So let's just kind of let me clean this to have space to solve effectively. I hope paying attention. So now, it's a find the force of repulsion between two protons of 1.6 times 10 to the power -19 coulomb each if the distance between them is this. So this is what I'm saying. Find the force here. So let's call it EG1 solution. So here is what they're asking to find. F is given us K as 1 over 4 pi E0 was 9 times 10 to the power 9 n squared charge squared inverse. Do you understand this? So they're giving us a Q1 and Q1 equal to 1.6 times 10 to the power -19 coulomb. So they said each. So Q1 and Q2 are the same. So 1.10 to the power -19 this. So they've given us the distance between them. That's R. R is on 5.3 times 10 to the power -11 meter. So you're just going to introduce the formula as 1 over 4 pi E0 Q1 Q2 over what? R squared. So that means multiplication. So let us compute everything here. So we have Q1 Q2 over R2K. Do you understand? So we're going to have something like this. 1.6 times 10 to the power -19 multiplied by 1.6 times 10 to the power -19 multiplied by the constant 9.0 times 10 to the power 9. Everything divided by 5.3 times 10 to the power -11 times 5.3 times 10 to the power -11. So here's what I mean. The radius is given as this. So radius squared will be this double. Do you understand? So Q1 and Q2 are the same. This is the double, and this is the K. This is it. Do you understand? So you can actually take your calculator, solve the above, solve the below, and get your final answer. But I ain't gonna waste your time. So we're gonna have our final answer as something like this. F equal to what? 8.2 times 10 raised to the power minus 8 Newton. Do you understand? So that's literally what you're asking us to find. Do you understand? So this is what you do with your calculator. And apply this. Do you understand? Sort out the standard form, divide it, and get something like this. Do you understand? So let's solve the other question. Okay, solving the second question. Okay. So in this aspect, now listen, in this aspect, there's something we call charge, we call capacitance, and we call velocity or potential, electric potential. So say a capacitance of 5 microfarad is subjected to a potential difference of 1000 volts across its terminal. Calculate the energy stored in the capacitor. Now listen, there's a formula for energy stored in the capacitor, do you understand? And there's a general formula to get quantity or charge, something like that. So this is general formula. The general formula is given as Q is equal to what? CV. So this is the charge. You understand? Charge. This is the capacitance. And this is the potential difference. Potential difference. All paying attention. So the formula for energy under this, we have the formula for energy under this, we have 1 over 2 QV or 1 over 2 CV squared. Why is it this? Q is equal to CV. So when you have CV multiplied by V, that's CV squared. So you can use any of these whenever you're getting the energy stored in a capacitor. So what are you asking us to find now? They're asking us to find calculate the energy stored in a capacitor. So they've given us capacitance, they've given us volts. So we're going to use this. Do you understand? So using this, so we have E is equal to 1 over 2 CV squared. C is 5 microfarad, and V is equal to 1000 volts. Do you understand? So micro means 10 to the power minus 6. Take note. Micro means 10 to the power minus 6. Okay. Let's introduce everything here. So we have E is equal to 1 over 2 multiplied by 5 times 10 to the power minus 6 multiplied by 1000, that's 10 to the power 3 squared. So we have E is equal to 1 over 2 multiplied by 5 times 10 to the power minus 6 multiplied by 10 to the power 6. So this cancels this. Do we understand? So we have 5 divided by 2. So E is what? 2.5 joules. So that was the energy stored in a capacitor. So for that, we come on to the end of electric field. You understand? We're going to solve more questions are going to be solved as a bonus for you registering for my courses. Thank you so much. I really appreciate you. See you in the next video.